Hello, this is Ms. DB. In this lesson, we are going to learn how to solve a system of equations using another method. We are going to use inverses. So first we need to determine whether a matrix has an inverse, and then we can use that to solve systems of equations using inverse matrices. A matrix can have an inverse only if it is a square matrix. A square matrix is a 2 by 2 or a 3 by 3 or a 4 by 4, but not every square matrix has an inverse. So there's a 2 by 2, here's a 3 by 3. I'm just making these up. If you have two matrices, let's say 1, 2, 3, 4, 2 by 2s, and 0, 1, 8, 1, I don't know. If we call this A and we call this B, these two are inverses of each other if A times B equals the identity matrix and B times A equals the identity matrix. Remember that matrix multiplication is not commutative. You would have to do it both ways to check. And the identity matrix is 1, 0, 0, 1 for a 2 by 2 matrix. So if it works both ways, then you would say that they are inverses of each other. There's an identity matrix that's a 3 by 3. All right, so we want to check if these two matrices are inverses. So we need to multiply them. If we call this A and this B, we need to check if A times B equals the identity matrix and if B times A equals the identity matrix. You could do this the way you learned how to do matrix multiplication in 4.2, I think it was, or you can use your graphing calculator, or you can use the online matrix calculator that I have linked to in your assignment and in your folder. This one was done using a graphing calculator, a TI-84, and you'll see that they did get the identity matrix. They got 1, 0, 0, 1, when they did A times B, and for B times A, they also got the identity matrix. Therefore, you would say that these are inverses of each other. Here's another one to check. Now, this one's a 3 by 3. That's more steps involved in multiplying by hand. But you have technology that allows you to just enter the entries of the matrix in, and then you can determine whether or not they're inverses by multiplying. When A times B was multiplied on a graphing calculator, it does not look like this is the identity matrix. So at this point right here, you could say that they are not inverse matrices because it needs to work both ways. So if you find that it does not work in one of them, then you can quit. But here's what it would look like if you did B times A, the other order, and that you can see clearly that that is not going to be inverse matrices then. We can find the inverse of a 2 by 2 matrix using this algorithm. If your entries are listed as A, B, C, D, then the inverse of it is 1 over the determinant times, and then you switch the entries like this. D goes up here, B stays, but you take the opposite of it. C stays, but you take the opposite, and A goes down here. So A and D switch places, and B and C get the opposite signs. If the determinant is 0, then you would say that you have no inverse. So if the determinant is 0, then you won't be able to finish this because part of this involves multiplying by 1 over the determinant. And we can't multiply by 1 over 0, so in addition to switching where A and D are located and taking the opposite sign of B and C, you also have to multiply that answer by the scalar 1 over the determinant. But again, if the determinant is 0, you say there is no inverse. So you should check the determinant first. So let's check the determinant. You would say 4 times 1 is 4, minus 2 times 3 is 6. 4 minus 6 is negative 2. It is not 0, so it has an inverse. So now we will do our flipping. We will switch where A and D are. So here was our original. We switch these two places, and we take the opposite sign of these two. So we now have 1, negative 3, negative 2, 4. but we also have to multiply this by 1 over the determinant. 1 over -2 is the same as -1/2. So we have to multiply every one of these entries by -1/2, which ends up being right here, this matrix. So this would be, now we can say, we put that like to the power of -1, which means it's the inverse of our matrix A. So again, find the determinant to see if it's defined. If it's not, then you don't even have to finish it. If the determinant is not 0, then we can find the inverse. All right, let's check the determinant. We would take, remember determinants, you multiply and then you subtract the other cross product. So 4 times 1/4 is 1. And then we have -3 times -1/3. That's the same as +1, but we're subtracting. So we have 1 minus 1 is equal to 0. So we would stop there. We would say that B has no inverse because the determinant was 0. Okay, we're going to check the determinant. That'd be -6 minus 6. Now -6 minus 6 is -12, not 0. Be careful there. So now we will switch the A and the D and take the opposite signs of the other two and then multiply by 1 over the determinant. So we switched the order of these two and we took the opposite signs of the other two. And then we have to multiply every single entry by -1/12. You can also use the graphing calculator or the matrix calculator online to enter the matrix into the calculator, and then there is an A to the -1 button, which means to find the inverse of that matrix. So you can double check your work using that. All right, let's determine whether the given matrices are inverses. So that's the one where you have to multiply both ways. We have to multiply A times B and see if we get the identity matrix, and then we have to multiply B times A and see if we get the identity matrix. Let's look at this one using the online mathisfun.com, this one here. All right, so I have already entered these two matrices into the matrix calculator. So I have -5, 0, 4, 1, and -0.20, 0.81. Yep, I got them right. Now I want to multiply A times B. So that's this one, this button right here. I get the identity matrix. Now to multiply B times A, you don't have to delete all this and type in the numbers. You can use this button to switch, and now they've just switched where now this one is first. -0.20, 0.81, and the second one is -5. So now I want to multiply again, and it's maybe you can't even see. Let me delete this so that you can see that something changed. When I multiply these, I also get the identity matrix. So you would say then that yes, this is the, can I write on here? Yes, inverses. And then you would do the same thing to check number 2 and 3. You would change these entries so that they match the worksheet, and then you would multiply, and you would see if you get the identity matrix. All right, for the next one it says find the inverse of the matrix if it is defined. So first thing we have to do is check the determinant. So the determinant is you take 1 times -1 minus 4 times 0. So that would be -1 minus 0, because 4 times 0 is 0, so we get -1. So the inverse is defined, and then we do this switch around thing. So we switch where A and D are. We have to take 1 over the determinant, and then we change. So that'd be -1 and 1, and we take the opposite sign of these two. And the opposite of 0 is still 0. The opposite of 4 is -4. So like that. Now I'm still going to check this with the graphing calculator or the matrix calculator. And then this means that I would take -1 times every entry because the determinant was 1 over -1 is the same as 1. So I would end up with 1, 4, 0, -1 is my inverse. Let's check this using the matrix calculator. So to check, I need a 2 by 2. Yep, got that. I'm going to enter in this original matrix 1, 0, 4, and -1 here. And now I'm going to click on the inverse of A. That's this here. Now it doesn't show A to the -1, it shows inverse of A. And they got 1, 0, 4, -1. 1, 0, 4, -1. Exactly what I got. So I checked it using the matrix calculator and I see that it's good. All right, now that you know how to find the inverse of a matrix, we can use this to solve systems of equations. It's very similar to solving a simple multiplication equation where you had 5x equals 20. You could multiply both sides by 5, which is the multiplicative inverse of 5. The inverse of a matrix is really the multiplicative inverse of the matrix. So we're just going to multiply both sides by the inverse. You have to do it in the right order because multiplication of matrices is not commutative. So we're going to write some different matrices here. We're going to write a matrix equation where A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. Here's what we got. If we had this system of equations, x plus y equals 8 and 2x plus y equals 1, the matrix equation, the coefficient matrix is the numbers in front of the variables. If there's no number there, it's a 1. So 1, 1, make sure it's in standard form, x, y, and then the number, x, y, and then the number. And the bottom row would be 2, 1, because 2 for the x and 1 for the y. Then we multiply by our variable matrix, which is x and y, since we have an x and a y in our equations. And then the constant matrix is what these are equal to, the number that they're equal to. We're going to use this a lot, so come back to this slide and look at it again if you need to. So to solve ax equals b, we can multiply both sides by a to the -1, because we already found out that the inverse of a times a is equal to the identity matrix. And the identity matrix times x is just equal to x. So this would solve for x, and we would get x equals the identity matrix, the inverse matrix times b, which was our constant matrix. All right, and again, you have to have that the inverse matrix comes first when you multiply on both sides. So our first thing that we're going to do is set up the matrix equation. There's a coefficient matrix, which is 2, 5, 5, -3, times the variable matrix, which is what two variables are being used. It's x and y. And it'll be equal to the constant matrix, which is the constants that both of those equations are equal to. Our second step is to find the determinant of A, because we're going to have to find the inverse of A. So we're going to need to know, first of all, if it has an inverse, and then find the determinant, because part of finding the inverse is 1 over the determinant times, and then you switch a couple things. So the determinant is 2 times -3 minus 5 times 5. So the determinant is -31. All right, so our determinant was -31. Here was our matrix equation set up right here. Here's our original problem over here. So we need to find the inverse. The inverse, it reminds us down here, is equal to 1 over the determinant, and then you switch the placement of the A and D entry, and you take the opposite sign of the other two. So we are going to switch these two and take the opposite sign of those two. And then we have to multiply that by 1 over the determinant, which is 1 over -31. This is just scalar multiplication, which means you just take 1 over -31 times every entry. And this then is this is the inverse matrix of A. Okay, so now we have to remember to solve this system up here, we multiply both sides by A to the negative 1. Because then these will cancel, and I'll be left with your variable matrix is equal to, and you'll have your answer. All right, so we need to multiply A to the negative 1, which is right here. It's not really A to the negative 1. It's the inverse of A times B, and B was 0 over 31. So I would use the graphing calculator or the matrix calculator to double check this multiplication. And when you do this multiplication, you get 5 and negative 2. 2 rows, 1 column. That means that x is equal to 5 and y is equal to negative 2. So our solution is a point on the coordinate plane at 5, negative 2. All right, this is another example. This one is from your assignment. So you might want to open up your assignment if you don't already have it open. And this is number 10. So we are going to write the matrix equation for this system. 2x plus 3y equals negative 1 and x plus 2y equals 1. So the first thing to do is to set up the matrix equation. So the first part is the coefficient matrix, 2, 3 for the top row, 1, 2 for the bottom row. You multiply that by the variable matrix, x, y, and that will be equal to our constant matrix of negative 1, 1. That's step 1. Step 2 is we're going to start working on finding the inverse of A. And part of that is finding the determinant. So the determinant is 2 times 2 minus 1 times 3. So 4 minus 3 is 1. Oh, it's nice when the determinant's 1. So that's going to make our work a little bit easier. All right, so here's our matrix equation again. So we have to find the inverse. The determinant was 1. So we only have to multiply this by 1 over 1. So we switch the order of these two, which doesn't change anything because they're both 2, and you take the opposite signs of these. So 1 times that is going to be, this is our inverse matrix right here. And then to solve, remember what we do is we multiply both sides by the inverse. But the inverse of A times A is just the identity matrix. So these cancel and you're left with the variable matrix of x over y. And now we have to do the multiplication. This multiplication is not going to be bad to do because of all the 1s. So you have 2 times negative 1 plus negative 3 times 1. So that's the same as plus 3. So 2 plus 3 is 5. And then the second row times this column would be negative 1 times negative 1 is 1, plus 2 is 3. So this one's not bad. So then the solution is x equals 5, y equals 3. This is number 11 from your assignment. I'm not going to do the whole thing, but I'll help you get it set up. So the first thing to do is to set up your matrix equation. So the A is going to be 4, 5. That's the coefficient matrix, and 5, 3. I already put that the variable matrix will be x and y, and it'll be equal to our constant matrix of 0, 13. So now, next you're going to find your determinant. Doesn't look like it's going to be 1, does it? So 4 times 3 minus 5 times 5. 12 minus 25 is negative 13. Okay, that's all right. It's all right if it's negative 13. All right, so let me set this up again. So this was 4, 5, 5, 3. And this was 0, 13. Now we need to go ahead and find our inverse. So here's how to find the inverse. Our determinant was negative 13. So this is going to be 1 over negative 13. And I know the determinant was negative 13. I was supposed to switch the 3 and the 4 and have opposite signs on these two. And I completely forgot about that, worrying about this multiplying by -1/13. So make sure you go back and fix that. This would be +5/13 because a negative times negative is positive, and this would be -4. And then that would be multiplied by b, which was 0.13. I didn't change that, that's not wrong. All right, so now when I use the multiplication calculator, whoops, here we go. Put my pictures back up. So this should have been put it over here, -3/13. And this was +5/13, and this was a +5/13, and this was a -4/13. And then our second matrix is only a 1 or a 2 by 1 with the entries 0 and 13, I believe. Yep. Okay, now multiply a times b. It's not letting me do it. So I would need to figure out a decimal version of these. You might be able to find a calculator, another matrix calculator that will let you enter in decimals or fractions instead of having to do this, because I'm afraid that this is not going to be exact because look at these crazy numbers. So that's unfortunate. However, this one is also not bad to multiply by hand. So maybe I should just do that. If I multiplied this by hand, I would have, all right, so I have this times 0.13. So the rule for multiplying matrices is you take the top row of the first one by the first column of the second. So we'd have -3/13 times 0 plus 5/13 times 13. 5/13 times 13 is 5. So I would get 5 for the first number. I have a lot of 5s. And then I would move down to the second row. So 5/13 times 0 is 0 plus -4/13 times 13 is -4. So yes, this one is easier to do without the matrix calculator because it's only a 2 by 2 by a 2 by 1, which is not a hard matrix multiplication calculation to do. All right, that's it. So I did a couple of these problems for you, and that should help you out. If you have questions on the other ones, please let me know or come to my office hours. Thank you very much. Have a great day.